Welcome to your Introduction to Statistics, Unit 4, Lesson 3. We're going to describe binomial distributions with their mean and standard deviation. So the mean of a binomial distribution is mu equals n times p. And remember, this can also be referred to as the expected value. And the standard deviation is sigma is equal to the square root of n times p times q. You'll be given the formula, so you just need to know when to use them and how to use them. So we're going to find the mean and standard deviation of the probability distribution for tossing 4 coins and observing the number of heads appearing. So n is 4, number of coin tosses. P is 0.5 because you have a 50% probability of successfully getting heads and 50% probability of getting tails. And so Q is also 1 minus P is equal to 0.5. So the mean would be n times p, so 4 times 0.5, which is 2. So you would expect to get 2 heads out of 4 coin tosses. And the standard deviation is going to be the square root of n times p times q. So the square root of 4 times 0.5 times 0.5. And so that's the square root of 1, which is 1. Okay, let's look at another one. This situation should seem familiar. A marksman takes 8 shots at a target. He normally hits the target 70% of the time. Find the mean number of hits, or the expected number of hits, and the standard deviation. So n is 8, p is 0.7, so it's q, it's 0.3. So mu is going to be n times p, so 8 times 0.7, which is 5.6. Now, notice somebody can't actually get 5.6 shots. That's okay. For means, you can be 1 degree of accuracy more than what's actually possible. So 5.6 is fine for a mean. In standard deviation, square root of n times p times q, so square root of 8 times 0.7 times 0.3, which gives us square root of 1.68, which rounding to the nearest tenth, since we rounded the mean to the nearest tenth, that's what we'll do with this standard deviation, is equal to 1.3. Okay, short lesson today. Do the problems to try on your own. Be ready to go over the problems in class, and I will see you when you get to class. Have a good day.